Welcome to my channel where I make everything in science, technology, engineering, mathematics comprehensive, assimilating, fun, and easy. We are continuing on straight line motion, and we are treating combining velocities and relative velocity. Kindly share, subscribe, and comment. Please don't forget, and we thank those who have been doing that. Thanks for your encouragement. Combining velocities is about effects of two velocities on a moving object. Most especially the velocity of the object itself and velocity of another thing in nature. Let's look at like boats or ship on waters. And aircrafts in air. So why do we treat this? So that you will be able to get the actual velocity of the body while moving, because these natural bodies like water up here, they also have their own velocities. So when they come, they don't just come and bounce back, they come in continuous motion, and that is why we talk about their velocities. I didn't mean they come, they go back, we talk about their force. So that one is another aspect. Now let's talk about combining velocities of boat or ship on water. The easiest one, or ship on water. The easiest one. Let's assume a river is wide like this, and the boats are this point. Let us say it is wide like 5 kilometers. Okay, let's make it bigger. Let's say it is like 15 kilometers. And a boat here wants to cross from this place to this place. You know, it will face like, and the river is flowing like this. Let's say it is flowing like 3 kilometers per hour. And this boat is on, without the water flowing, on still water, it can move by 4 kilometers per hour. And you know, this water, this river, flows continuously. It will continue like that while while the boat is moving. So, which means that when the boat, let's say after 1 hour, the boat would have moved 4 kilometers. But this river would have moved the boat away from its actual path that it was taking. So we call that one track. So this will be its new track, its real track. Do you understand now? So this boat will come to this place now. It is just like, I want to get to that place, and there is a force pushing me like this. So it means that as I move my leg once, the force will push me to this side. I move it once, the force pushes me to the other side, to this side again. So that is it. So let's see again. It moved down 4 kilometers. The next hour, the river would have pushed it another 3 kilometers. So, which means that at last it will get like this. So, which means the actual path it wants to take, the river would have pushed it away from the destination it envisaged initially. It would have moved it, let's see, this is 15 kilometers. So, it means that if the boat will move this place, it will be normally 15/4, which is 3 hours, 3/4 hours. And which means that it would have moved sideways again by 3/4 hours times 3. And if you look at this, using Pythagoras, it would have moved, this one is 5 now, this one is 5 again. So it would have moved down like that, as in 5 times 3/4 kilometers. So that is the major thing we look at in combining velocities, and it's very interesting. Another thing is sometimes it might not be perpendicular to each other. So the motion and the direction of the body in nature with the actual body we are moving, like air or water, and the ship or plane will be considered to get the actual path, and this will help the sailor or the pilot to direct the ship or airplane so that it can maneuver it maybe towards this side. So at the end of the day, by combining it with the motion of the air, it will get to its actual destination. Let's look at another example. Now I have a question. A river is flowing at 3 kilometers per hour. A man sets out at right angles to the banks to row across. He can row at 4 kilometers per hour in still water. What is the actual velocity across the river? Just the same like what I did now. So it is going to be something like this. So the river is flowing like this, and the man's motion is like this. So it will be like this. So this is 3 and this is 4. So this is 3 kilometers per hour. This is 4 kilometers per hour. So what you should know is that when the velocity is being combined, it is added, and the addition is in vector form. So you are going to add it like this: 4 squared plus 3 squared, and this is the velocity across, and that will give you 5 kilometers per hour. So you should know the direction at the same time. So the direction here will be that is very simple way of handling it. In combining velocities, it is addition. When we get to relative velocity, it is subtraction. That's why we call it relative velocity. Let's try another example. A helicopter has an airspeed of 100 kilometers per hour and flies on a course bearing 150 degrees. A wind is blowing steadily at 30 kilometers per hour from a bearing of 080 degrees. Find the track and ground. Now let's look at it. You can use your vector, you can use your construction, you can use your normal calculation to solve it. So those 3 or 4 techniques makes it very easy. And by the time you look at the problem, you'll be able to see, oh, this is the technique I'm going to use. Now, we are told it's 100 kilometers per hour, flies on a course of 150 degrees. Just like in bearing. So this is 150 degrees. And this is 100 kilometers per hour. Now, we were told that a wind is blowing steadily at 30 kilometers per hour from a bearing of 80 degrees. So this is it. So this is 80. So we have this place. 80. 80. So this is 10, 10. And this place is 150. So we are going to have something like 30 here. I hope you understand. We are going to have something like 30 here. And the track now, if you look at it, is going to be something like this. Because this is where the plane is going to. So we are going to have something like parallelogram. You can see. So can you see now? So this is what we have here now. Then, if you look at this, this place is 110. This place too will be. So this place is going to give us 70 degrees. And we have this place to be 100 kilometers per hour, and this place is 30 kilometers per hour. So if you look at it, I said you can use your vector, you can use your construction, just like we do in locus. You can do it straight. So if we use our calculation now, this is our V, and this is the direction of our V. So we can get this plus this place is 60, you know. So let's quickly do that. This place is 100, this place is 30. So I can say, let's use our cosine rule. So we have V squared equals 100 squared plus 30 squared minus 2 times 100 times 30 plus 70 degrees. So we have this to be 10,000 plus 900 minus, this is 6,000 or 70, and that will give us 8,847.88. So V is equal to 94.06 kilometers per hour. That is V. So that is 19.06 kilometers per hour. And the direction, that is the track. This is the real motion of the plane now. This is the real motion of the plane. So the track now, we can find that by saying, okay, V over sine 70 is equal to 30 over sine alpha, and we add it to this. Now let me get it. Let me get the alpha now. V over sine 70 is equal to 30 over sine alpha. So sine alpha will be equal to 30 sine 70 over 94.06. And that will give us 0.2997. So alpha will be equal to 17.44. So the actual direction of the aircraft is equal to, you add this one, we add 60 here plus 17. So we have 150 plus 17.44. It is equal to 167.44 degrees. So that's the actual track of the. Let's say I want to use vector to work this out. The velocity of the aircraft let me call that one VA, of the wind, let me call it VW. So VW, if you look at it, it's going to be 100 sine 100 cos 60i minus 100 sine 60j. For the wind, this is V, sorry. VW will be, this is 80. So I'm going to have minus 30 because it's towards this direction. Cos 10, and that of at the same time I have minus 30 sine 10j. You know this is 880, so this place will be 10 and this place will be 10. Now, because it is combining, they are combining together. What will I do? I will add the two. It's going to be a resultant effect. So V, that is V, will now be equal to, let me sum these two. So this one is I, please, and this one is J. So in this instance, I resolve each of them. So on addition, I got this, and this is the magnitude of the velocity. Now I will find the direction. This is the direction now. I will get the actual direction. So which means that whatever I get now, I will add to 90 degrees. So you can see now, if you go by vector, just adding the two, you can see what we got. So straightforward. It's very easy. Another thing is you can use your construction. I said it initially, like locus. You get the answer straight and direct. So it's very, very easy. Let's look at another example. An aeroplane leaves an airfield A at 1 p.m. to fly to another airfield B 400 kilometers away on a bearing of 130 degrees. There is a steady wind of 30 kilometers per hour coming from the northeast. The aeroplane has an airspeed of 200 kilometers per hour. Find the course the pilot must take and the time of arrival. Now we have this. There is an aeroplane trying to move from one airfield to another place. And we are told that he leaves at 1 p.m. to another airfield 400 kilometers away on a bearing of 130 degrees. So we have this like this. So that is the other airfield. And this is 130 degrees. And we are told that this is 400 kilometers. And we are told that there is a steady wind of 30 kilometers per hour coming from northeast. That is, this is, yes, so which means it is coming like this. Northeast. And when they say northeast, it means 45 degrees. 45 degrees. This is northeast, so it is coming this way. And we are told that this is 30 kilometers per hour. Another information we are given that the actual speed of the plane is 200 kilometers per hour. That we should find its course. And what does that say? It means that the plane should fly in such a way that at the end of the day, its resultant must be on this 130 degrees. So we are going to mix the two the resultant of the velocity must come on this 130 degrees. So it is the angle that is our concern for now. Now let's see. Because if you move it down like this, it's going to move it like this. So the plane is going to be like this at this place. And like this again. And like this. Oh. Sorry. It's going to be something like this, 30 kilometers per hour. And then, yes, so that the resultant should be here. So V should be here. And this is 200 kilometers per hour. So we have this place, we have this direction here now. We have this place. This is 130. Yeah. And we have this place to be 45. So if this is 130, we are going to have this place to be 50. Because this is 180 minus 30. And this place will be 45. Very good. And we also have this place as 200 kilometers per hour. So if you look at this, we have gotten, if this place is 95, it means that this place too will be 95, yeah. And it means this place will be, I think, no, we can't get like that. So we are going to have this place as 95. So thank God we have one complete, so we are going to have something like this. So we have 95, 30, 200, and this is V. 30, 200. So let's find this place first. This one, before we get V. So it means that, let's use sine rule. Sine theta over 30 degrees over 30 kilometers per hour is going to give us sine 95 degrees over 200 kilometers per hour. So sine theta will give us sine 95 times 30 over 200. So let's see what sine theta is. So if you had used construction, you would have gotten it straight. But since we are using calculation, let's see. So this one is 0.1493. So theta, this angle here is going to be 8.594 degrees. So we have this place as 8.594 degrees. So we can find our V because we can get this angle now. This angle is going to be 76.41. So we can find our V now. We can say sine 95 over 200 is equal to sine 76.41 over V. So V will be equal to sine 76.41 over sine 95 times 200. Let's work it out. So V is equal to 195.14 kilometers per hour. So that is our V. And we can get, so let's see the direction. by which this will actually move. So the cost of the plane will be equal to 130 minus 8.594, and that will be 121.41 degrees. So the time it will use to take the journey is going to be this velocity, 400 over this velocity. Time for journey will be equal to 400 over 195.14, which is equal to 2.1 hour. So, but we were told that he left at 1 o'clock. We were told that he left at 1 p.m. So, the time by which he arrived at this place then. So, time of arrival will be equal to 1 plus 2.1 hour, which is going to be 3, and that is 0.1 of 60. That is 306. That will be the time of arrival at the other airfield. Okay. So the time for the journey is 2.05 hours. 2.05 hours. So the time of arrival will be 2.05, and that is going to be 3 o'clock plus 0.05 times 60 minutes. So it's going to be 3.03 p.m. That's the time of his arrival at the other airfield. If we are to use vector also, it is very easy and straightforward. What we do is just to find, we will resolve the vectors along the path. We will resolve the vectors along the path we wish the plane to take, and that will make our workings easy. It will make our workings easy since we know these ones. So it's better we resolve it along this path. Let's see how it goes. Now, for this kind, I love resolving it along the plane because you have been given the path. So, because if you are trying to solve it in another way, it will be too difficult. Yes, you can get your answer, but if I have the time, I will do that. Now, we have been shown that this is 95 degrees, but you don't know this angle here, theta. Now, let us resolve it along the plane, along the resultants. Now, the way I solve this is to make it easy for me, because if I solve it along the normal x and y axis, it will be strenuous. But with this, it makes it easy for me. So I resolve it along the plane of the resultants, the axis of the resultants, and the perpendicular direction too. Now this is the perpendicular to the resultants, and that is our V now. So look at it now. So I have 5 here, I have 90 degrees here. That makes it easy for me. Along this place, that is V. So 200 cos theta. If you remember this scalars and vector we treated, the component of this along this place will be 200 cos theta. So let's call this place I. Minus 30 sine 5 degrees is equal, this is I as well, is equal to V. If you look at it, is V. But along the perpendicular direction, V doesn't have any components because of what you have done now. So, along the perpendicular direction, we have 200 sine theta minus 30 you can see, because V does not have anything along that component, so it makes my work easy. Now let's quickly find theta here now. So we can say 1, 2. So 200 from 2. So sine theta equals to 30 over 200 cos 5. So I can find theta now as sine over 200 cos 5. So you can see my theta is 8.594 degrees. So the path of the plane is equal to 130 minus 8.594. I believe we've gotten that one before. And this is 121.41 degrees. You can see. So if you do the right thing, it is very easy. So by calculation, by construction of vector, you get it. Now, I can easily get V now. So it is going to be 200 cos 8.594 minus 30 sine 5 is equal to V. You know, that's the only component for V in this instance. So let's quickly work that. So the answer is still the same. 195.14. So it depends on how, just play around with this thing. It's fun. Just play around with it. Let's look at the next question. The question now says, what course should the pilots in the previous example take for the return journey if the wind continues as before? Very easy and straightforward. Now let's look at it. It's now on the return journey. So the field will now be, the direction of the field, the next airfield will now be 360 minus 50. 360 minus 50. That's going to be 310 degrees. So all this place here now is 310 degrees. Let's get that one. So that is the fact now. So we have 30 kilometers per hour. We have 85 here now. Because this place is 40. This place too will be 40. Vertically opposite angles. That is 40 for us now. So all this one here now, from here to here now, is now 85 degrees. So we have this place 30, 85, and then let's call this place beta now. So just like we did the other time, we can calculate this place and then we find our v. So let's see. Sine 85 over 200 is equal to sine beta over 30. So sine beta is equal to 30 sine 85 over 200. 30 sine 85 over 200. So that gives us so beta will now be equal to 8.594. I think it's giving us something similar to that. So since we have this place as 8.594 degrees, so this place too will be beta. So it will be beta plus 310. So direction of the plane, part of the aircraft will be equal to 310 plus 8.5. So the path of the aircraft is 310 plus 8.594, which is 318.594 degrees, approximately 319 degrees. So that is the path of the aircraft. So that will be the direction of the plane on its return journey. Let's now find v. Now to find v, you have to find this place. Let's call this place gamma. So we have 85 plus 8 points. So this place is going to be, so gamma is equal to 180 minus 85 plus 8.594. And this gives 86.41. Let's make it like that. So we can find our v now. So sine 86.41 over v is equal to sine 85 over 200. So v will be equal to sine 86.41 over sine 85 times 200. So we can find the v now. So v is equal to 200.37 kilometers per hour. So that is the, although we are not told the time he lifted from this place, but the time for return journey, will be equal to 400 divided by, that is 1.996 hours, and if you convert it to, it's going to give us (1 hour), let's say 2 hours approximately. is going to give us 2 hours. So that's the time for return journey. You can try it with vector and you will see that it will be very easy at the same time. So using vector analysis, I like you to use that as exercise and you will see. Thank you very much. I believe you comprehend everything we have done, and kindly send any question for clarification or whatever. Kindly send. And if you feel like any suggestion, it is welcome, please. Your comments, subscribing to our channel, and sharing this thing will be highly appreciated. Thank you very much for all your support and for your patience for this lecture. Thank you very much.